Today we'll discuss about Coulomb's law. So Coulomb states that the force between any two charges is equal to K into Q1 into Q2 by R square, where K is the Coulomb's constant, Q1, Q2 are the charges of the two bodies, and R is the distance between the two bodies. Okay, so Coulomb states that force between the two charged bodies will be equal to product of their charges multiplied with Coulomb constant divided by square of the distance between them. So Coulomb constant is 9 into 10 to the power of 9, where K is equal to 1 by 4 pi epsilon naught. So when you calculate, you will get the value as 9 into 10 to the power of 9 Newton meter square divided by Coulomb square. Okay, so this Coulomb law is applicable only to point charges. This is most important. It is applicable only to point charges, that is charges at rest. Okay, for example, we can consider two bodies, charged bodies having charges Q and another charged body having charges plus 2Q, and they are separated by a distance of R. So it is applicable to point charges separated by a distance of R. So point charge is a charge that is located at a point. Okay, so what is the type of force between the two bodies? It is a repulsive force because it is a positive charge, and B also has a positive charge of plus 2Q. So plus Q plus 2Q. So it is a repulsive force. So what could be the value of this repulsive force? What is the magnitude of this repulsive force between the two charged bodies? That is repulsive force experienced by A charge due to B and repulsive force experienced by B charge due to A. So repulsive force of one charge to the other charge. Okay, so A repels B and B repels A. So what is the repulsive force? Then we can find it out using the Coulomb's formula. F is equal to K into Q1 Q2 divided by R square. Okay, with the help of this formula we can calculate the force between two charged bodies. Next is gravitational force. So this gravitational force is due to the attractive force between the bodies on the earth. Okay, so earth exerts a force on all the bodies near its surface. Okay, so this force is called as gravitational force, that is the force due to gravity. It is given by F is equal to capital G product of M1 into M2 divided by R square. So what is G? G is the gravitational constant, 6.67 into 10 to the power of minus 11 Newton meter square divided by kg square, and M1 M2 are the mass of the two bodies. Okay, M1 and M2 are the mass, and R is the distance between the two bodies. Okay, always the gravitational force will be an attractive force. Okay. Okay, now we will come to the first objective type question. What is the electric force between two electrons? Okay, what is the electric force between two electrons? Is very large as compared to its gravitational force, true or false? Electric force between two electrons is very large. Whether it is very large when compared to its gravitational force? So we have to, generally we know electric force is always greater than that of gravitational force. Just we can take an example to look into the statement. Okay, so we know the Coulomb's F is equal to K into Q1 Q2 divided by R square. Okay, so K is a constant, 9 into 10 to the power of 9, and Q1 Q2 is the charge of electron. Both the charges are equal, so it is 1.6 into 10 to the power of minus 19 Coulomb, and assume that distance is equal to 1 centimeter, which is equal to 1 into 10 to the power of minus 2 meter. So just you convert the centimeter to meter. Okay, now substitute this formula, electrostatic force formula, Coulomb's force formula. We will get 9 into 10 to the power of 9 into 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19. Okay, 1.6 into 10 to the power of minus 19 the whole square. divided by 1 into 10 to the power of minus 2 the whole square. Okay, so after multiplication of the, we'll get 23.04 into 10 to the power of minus 34 Newton. F is equal to. So otherwise you can write it as 2.304 into 10 to the power of minus 33 Newton. Okay, this is the electric force. Okay, next we can calculate the gravitational force. So we know the formula for gravitational force. F is equal to G into m1 m2 divided by r square. So G is a constant which is equal to 6.67 into 10 to the power of minus 11. m1 is equal to m2 is nothing but mass of the electron, which is equal to 9.11 into 10 power minus 31 kg. Okay, so just to substitute all these values in the formula, we'll get 6.67 into 10 to the power of minus 11 into 9.11 into 10 to the power of minus 31. 2 times m1 m2, both the values are same, so just I'm putting 9.11 into 10 to the power of minus 31 the whole square. So m1 into m2, right? So both the values are same, just put it as square, divided by 1 into 10 to the power of minus 2 the whole square. Okay, so after doing the mathematical calculation, you will get the values as 5.5 into 10 to the power of minus 67 Newton. Okay, so now you compare both these values. So when you compare both the, this is for the electric force. Okay, so this we have calculated for electric force, and this we calculated for gravitational force. So when you compare this, which is larger? Exactly, this electric force is larger. F is equal to 2.304 into 10 to the power of minus 33. It is into 10 to the power of minus 67. So very small value when compared to electric force. So from this we conclude that electric force is greater than gravitational force. So the answer is true. Always the electric force is greater than gravitational force. Okay. So just remember the two formula, Coulomb's formula and gravitational force formula. Just substitute the values and you can find it out which is greater. And generally electric force is always greater than that of the gravitational force. Okay. Now we'll come to next problem. Two equal and opposite charges are placed at a distance r. The force between them is F. If distance between them is double, then the force between them is, what is the option? Okay. So two equal and opposite charges. So two equal. So let it be Q1 and Q2 be the two charges. Both are equal. So let it be Q. Okay. Both the charges are equal. And they are placed at a distance of R. So distance is R. Okay. And the force between them is given as F. F is the force between them. So F is equal to Coulomb's law, K into Q1 into Q2 will get Q square divided by R square. Okay, Q1 into Q2, both the values are Q, equal values, so we'll get Q square by R square. This is your F value. Okay, let it be 1, equation 1. Now, what happens if the distance is doubled? When distance is doubled, distance R is changed to 2R, then what could be the force? Okay, so when the distance is doubled, F is equal to K into Q square divided by 2R the whole square. So which is equal to K Q square by 4R square. Okay, just rearrange it. KQ square by R square into 1 by 4. Just you are rearranging. So what is this k q square by r square? So from 1 it is f. Okay, from equation 1 it is the value of f. So you can write it as f. So let the new force what you are finding, let it be f dash. Okay, so f dash is equal to f by 4. So what you have done is they are given two equal and opposite charges. So q1 equal to q2 equal to q, are assuming as q, and distance is r. So substitute in the Coulomb's formula, f is equal to k into q1 into q2 divided by r square. Okay, q1 q2 both are equal, so you can write it as q square divided by r square. Okay, next, when the distance is double, let the force, we can take it as f dash. Then substitute in the Coulomb's formula, k into q square divided by 2r the whole square. So 2r the whole square becomes 4r square. So rearrange it to k q square divided by r square into 1 by 4. This k q square divided by r square is nothing but your f. Okay, f value. So therefore f dash is equal to f by 4. So the option is, answer is A. So from this what you conclude? As the distance is increased, the force has reduced. Force value is reduced. So force is inversely proportional to 1 by r square. Okay, distance increased, force gets reduced. Distance reduced, force magnitude value gets increased. So next problem is two equal and opposite charges are placed at distance r. Okay, same. The force between them is F. If the distance between them is halved, then the force between them is what? So we know that F is equal to, force between them is K into Q square divided by R square. Okay, so from the same one equation, both the charges are equal, same thing. Now we are going to half the distance between them. So in this case, distance is reduced, r by 2. Okay, so in the earlier case, distance is doubled. Here distance is reduced to half. Okay, so the new force F dash is equal to k q square divided by r by 2 the whole square. So which is equal to k q square divided by r square by 4. So this 4 goes to the numerator, so we will get 4 q square divided by r square. So this 4 q square divided by r square is nothing but f value. Okay, so we'll get 4f. So new force F dash is equal to 4f. Okay, so the option is B. Answer is B option. So from these two problems, what do you understand? Here we are decreasing the force because as the distance is double, force value is getting less. Here if we check it out, when the distance is reduced, here distance is reduced by half. So when the distance is reduced, what happens? Force magnitude is increased. Okay, so distance reduced, force magnitude is increased. When distance is double, force value gets decreased. So force is inversely proportional to the square of the distance between them. So next is force between two charges is F. If a sheet of Pyrex glass, this Pyrex glass is nothing but the glass which can withstand high temperature. Okay, so dielectric constant value is given, is placed between the two charges, then what will be the force between the charges? So default conventionally we say that the two charges are in free space. Okay, default free space, we say the charges are in free space or in vacuum. So for free space air, the dielectric constant is always 1. Dielectric constant K is equal to 1. Okay, for free space. So whenever a dielectric substance comes in between the two charged bodies, then we have the dielectric constant. Here a sheet of glass is used. Okay, so glass is used. between the two charged bodies, and this Pyrex glass dielectric constant is denoted by the letter K is equal to 5. Okay, dielectric constant is denoted by the letter K, which is 5. So what is the relationship between the force in free space and force in some other medium? So force in free space, okay, is equal to force in other medium, other dielectric substance, divided by force in free space is equal to force in other medium divided by the dielectric value. This is the relation between the force between the free space and the force between other medium. So here the force between the glass substance. Okay, so this is force between the free space. So let the force between the free space be F. Okay, and the force between the medium. Okay, so the force between the medium is given by F dash. Okay, is divided by 5. Okay, 1 second. Sorry, I have told the relationship wrongly. So the force between the new medium, force between the new medium F dash is equal to the force in the free space R divided by the dielectric value. This is in some other medium. So earlier it's a mistake, sorry. So force in new medium is equal to force in the air divided by K. So force in the air always F divided by K is a dielectric constant given as 5. So F by 5. So F dash is equal to F by 5. Okay, so option D is the answer. Okay, next question is find the electric field, okay, between two charges. The charges value is, let Q1 is equal to two charges be Q1 and Q2 microcoulomb. So microcoulomb is nothing but 0.4 into 10 to the power of minus 6 coulomb, and Q2 is equal to 0.8 microcoulomb, which is equal to 0.8 into 10 to the power of minus 6 coulomb, separated by a distance of r is equal to 0.12 meter. Okay, now we have to find the electric force. Okay, so we know the formula, Coulomb's formula, F is equal to K into Q1 Q2 divided by R square. So K is a constant, 9 into 10 to the power of 9 into 0.4 into 10 to the power of minus 6 into 0.8 into 10 to the power of minus 6. Okay, so just calculate it. So 0.12 the whole square. Okay, so when you calculate this, we'll get the answer to be 200 into 10 to the power of minus 3 Newton. This can be written as 200 divided by 1000. So you can cancel this. So we'll get it as 0.2 N. Okay, so value of F is equal to 0.2 Newton. Okay, now what you have to do, second subdivision is, the distance between the charges is double, then find the electric force between them. Distance is double, so R has increased to 2R. So we know that when the distance is double, from the previous problem what we get, distance is double, the relationship between is new force F dash is equal to F. Okay, F by 4. We have derived this, right? So F dash is equal to F by 4 when the distance is doubled. Okay, so just substitute the value. So F value is 0.2 divided by 4. Okay, so which is equal to 0.05 M. So what do you conclude from this? When the distances are, the force is 0.2 Newton. Okay, When the distance is 2r, the force is 0.05 Newton. So as distance is doubled, force value has force is decreased. So force is inversely proportional to the distance. Okay, students, the continuation next problem will be in my next video. Please check the link which I given in the description box. Thank you, students. Please subscribe the channel and share with your friends. Thank you. Please watch the next question in the next video. Soon we will be meeting you in the next video. Thank you.